So what you're going to do, open up both packs of M&Ms. You're going to count. Probably easiest to separate them like Malachi did there. Separate them. Then count them. On your paper, you're going to write it down, how many you have, just in one of the columns. Then you're going to come up here, you're going to write your name. We don't need 700 people up here at once. But you're going to come up here, you're going to write your name. And then just put in your numbers and your total for your total M&Ms for the 2 packs. Take a couple minutes, do that. Once you have your totals written down on your paper, sort of orderly fashion, you can start going up there, write yours in on the board for me. I'll tell you what. Let's do this. Let's see if we can use this pen so we can actually record it. Bryce, is it all right if I write your name? Sure. So just use that pen so we can actually record it on the thing and keep it for posterity. Is that what it is? Keep it forever. Yeah. Yes. Yes. How's that fair? Jacob at 32 and
I only had 21.
no, that ain't fair. I had 33. Must be because Jacob's related to me, so I like him more. More M&Ms.
I'm sure that's how it
works, right?
I'm sure.
Come on, Michael, you didn't have 0 yellow, did you? Yeah. What in the world?
Hey, Jake.
Michael. I'm not calling him Mikey, he's too old to be called Mikey. Mikey B. Get 21? 30. I'm a man. Now, you guys are up there writing this. First thing, realize how hard it is. See, poor Malachi's trying to stand out of the way and write at the same time. So when I'm up there and I look stupid because I'm looking like a gymnast or something, just remember that and say, well, I feel sorry for poor Mr. Eversole. The whole body, got to do all that stuff. guys have been through enough math classes to know, first chapter 2 in a math class normally is what?
Easy.
Normally review, right? Not that way in this class, but the first chapter or 2 are like a lot of basic stuff. So it's a lot of definitions and a lot of things that you'll need to know for the entire year. What is a sample? What is a parameter? What is a statistic? What is data? Nah, you don't have to write over. You can if you want, but you don't really have to. Ms. Clark, I lost my paper that I normally hand out to you guys. So that one I just printed off the PowerPoint, because usually it was just I think it was just a one-line thing where you just had your, you said how many red, blue, I couldn't find it this year. I don't know what happened to it. Yeah. Molly, what's James doing?
Video games. Playing video games. Oh, that's great.
Working anywhere?
Movies.
Sophie, what's your brother's doing? Thought I seen one of them last night at the soccer game.
Probably.
I still don't know which one. I never
Who's Josh?
tried to distinguish between the two.
Who's Josh?
Who's Josh? Hell, you play baseball this summer? You hurt right now? You hurt?
I'm getting one.
Hey, how you did it?
What'd you do?
Oh, wait.
It went away. Your number went away.
Sorry, Miss Clark.
You're fine.
What is that one number?
30.
That's an 8.
It's an 8.
Yeah.
Hold on before I grab your pen. Alright. Are we done? Is that everybody? Yes, no, maybe? 3, 6, 9, 12, 13. There's more than 13 maybe. Come on, Molly. Who else is in up there? I thought we had 15. Don't make me go through the names. You won't got any up from the class. Been doing it for 20-some years. I ain't dead yet. This one would be the last. That's everybody, right? Now, give me about 2 or 3 minutes. You need your M&Ms. While I'm doing this, if you get done eating your M&Ms, somebody wants to help me could get out a calculator maybe and total up his bottom line. The other numbers I can probably do pretty well in my head, but the bottom line I might mess up, so we want to make sure that I'm right. Yes, you could use the phone for today. Maybe we should not be recording this in case I mess up. Make me look pretty bad if I can't add.
Take mine.
So if you had some 4, right?
Yeah.
I got the number.
Huh?
You got the number yet?
Oh, the bottom one? Let's see if I get it right. Michael, that's a 3, right? Yeah. All right, on this, so whole purpose of doing this, number one, just to something easy to start us off with. But some of the stuff we're going to talk about today, all this is data. All right, we have different kinds of data, and when we're dealing with in the math course statistics, one of the pieces of data is a statistic. And that's what we're dealing with here. And we'll learn next class that you have quantitative and qualitative data. Quantitative, what do you think quantitative is? What words that come from? Quantity. So what do you think it deals with? Numbers. So quantitative is numbers. Qualitative, what kind of qualitative data do I have up there? names. What else? The colors. That's a quality. Alright? So like color of your hair, color of your eyes, your height, your weight, those are all qualities, but if you start dealing with numbers, then it's a qualitative or a quantitative data. So different things there. We won't do this. I know this class is called probability and statistics, but we do a whole lot more statistics than we do probabilities. So just to do a little probability here, just to talk about this a little bit. First thing, does any numbers really jump out there? 143. Why? There's a lot more blue than anything else, isn't there? There's a lot more blue. How come there's a lot more blue than anything else? Anybody have a? This isn't something where you could be wrong. Favorite color? Maybe. So maybe the people that's working at the factory, they like blue a whole lot better than the other colors. Blue tastes better? Maybe. Now, I don't know if I'm right or not, but my guess is why there's more blue is a few years ago, I don't think there was blue. They had other colors, and then they put blue in. And so now it's one of those things where they have a whole lot more. Which color has the fewest? And this is different than any other year I've ever done it.
Yellow.
Yellow. That's usually not the case. Why do you think, let's come up with a reason why we had fewer yellow this year, and that's never ever been the case any time I've ever done this. How come they made more other colors maybe? What do you, let's try to think about, how do you think they mix these? Think they got somebody sitting there putting them in these little bags? You got big vats of all these different colors of M&Ms. So maybe on this day when the bags that we have, when they were made, who knows what happened? Maybe the yellow vat wasn't working right or something that day. Maybe they had some yellow left over from the night before and they just mixed that in and didn't make any new yellows. Who knows? All right? Any guess as to which one normally is the fewest? Brown. No idea why, but every year I've ever done this, brown's always been the fewest. This is the first time ever that one of the other colors was lower than brown. And red's right down there with brown. Now red sometimes is really, really close to brown. And you guys won't know this. I do know why red is one of the fewer, or has fewer in there. Huh? That's sort of what happened many, many years ago when I was growing up. And yes, they did have M&Ms back in. The food coloring, or the coloring for red, somebody decided that it caused cancer. So they quit putting red M&Ms in the bags. And they just came back a few years ago. Alright? So make sure you get rid of all the red ones, Dalton. Don't. So they put them back in there, but you still got people like me who grew up during that time thinking, I'm not eating the red ones because they cause cancer. Other things we could do with this, and some of the things that we're going to do with this as we go throughout the year. And if you have a phone that has a calculator on it, you can get it out and help me out for today. But you will, and that's something I need to say, and I'll get to it here in a minute about the calculators. We do need to get a calculator. How could I make this look more sensible by changing all those numbers into a what? That would make more sense to everybody, right? And that's a lot of what we'll do this year, is change the numbers so that they make more sense to the whole group. If you go home and you tell your mommy that there was 48 brown M&Ms out of 467, that's not going to mean anything to them. So somebody help me out. What's 48? If we write that as a fraction, what's 460 or 48 divided by 467? One time you're going to be allowed to get your phone out. Do it. Help me out.
Yeah, I got 40.
0.10, what is that as a percent? 10%. So about 10% of all the M&Ms were brown. Let's try the blue. 143 out of 467. 30%. 31. We'll go with 30 since I already started ranking. So about 31%. Make up a statement for me about, and you'll have to do this a lot throughout the year too. Make up a statement for me comparing blue M&Ms to brown M&Ms. Don't say blue is better than brown. That's not mathematical. That's not what we're going to be doing with this stuff. Could be in chickens. What could you say how blue and brown are related?
There's 3 times the amount of blue and brown.
That easy. 3 times. Looks like normally there's about 3 times as many blue M&Ms as there are brown M&Ms. Again, why might that occur? You said it earlier, Malachi.
Favorite color.
More people like blue than brown, right? If I went around the room and asked people their favorite colors, more people are going to say blue than brown, probably. All right, so just a basic idea again, data, collecting data. We're going to do a lot with charts these first couple of chapters. You're going to hate charts after these first 2 chapters because we got these charts that are like a mile long that you got to fill in everything. Nothing really hard about them, just a lot of work. All right? So you'll have to do something like you'll have this column, then you'll have to add 2 to it and get this column. Then you'll have to times it by 3 and get this column. Then you have to so on, so on. And it'll be about 15 things across this whole chart that we have to do. All right, introduction to statistics. Get rid of this. Let's go. What we're going to do in section 1, and as you do notes for in here, I would get out a piece of paper and I would write some of this down. This is totally up to you. If you need paper, there's extra paper up here. There's also pencils up here. If you have any extra pencils, you find a pencil on the floor, put it in that cup up there, and we'll try to keep something extra up there for the entire year. When you write down these notes, in no way, shape, or form do I want Miss Miller to write down every single thing that's up here, because if you do that, we're never ever going to get through everything. All right? So you got to write down what you're going to need. And for this, a lot of you are writing it down already, and you're going to get mad at me because I'm getting ready to switch this slide. I wouldn't write any of this down. All right? There's going to be key things, and I'll try to point them out as we go, that, hey, I would probably write this down. What we're going to talk about today, defining statistics, distinguishing between a population and a sample. Let's go ahead and do that right now. Population and a sample. If I have any idea what a population would mean? everything, right? The whole population, what's a sample? Just part of that population, right? Key thing for statistics, populations and samples. We don't deal with populations a whole lot because, let's say I wanted to even go out just today and do some kind of survey to every student at National Trail. What would happen? Would I be able to get it done today? No, because we got people like Mr. Washington that skipped out on the first day. All right? It's hard to get a population. You're not usually going to be able to find the whole population. They try to do it whenever they do the census, but you know, when it comes that census time and somebody's knocking on your door and your parents are going, because they don't want to have to sit there for an hour and do the census, right? Or they get it in the mail and it lays there on your table for 6 months, all right? It's about impossible to get an entire population. So we try to pick samples. And when we try to pick those samples, we try to pick samples that mean something. Like if we wanted to make a decision today about the dress code at National Trail, could I use you guys as a sample and just run with it from there? Probably not. Why not? Maybe not enough. What else would cause the sample to be a little biased? You guys are all upperclassmen. Maybe you don't think like the freshmen or the sophomores, all right? So it makes something a little biased, and we want to try to get samples that show the entire population. Presidential election last year, seen them all the time, and last year was a good year for statistics because you've seen them on the news all the time. When they were doing those samples, oh, so-and-so's leading by 16 points. And then everybody was surprised when Trump won, right? Because all the polls and stuff they'd shown showed Hillary leading by like 16 points here, 15 points there. Well, what's that tell you about their samples that they were taking? They weren't very good. Distinguish between a parameter and a statistic. Easiest way to deal with these, a parameter goes with the population. A parameter is a number that deals with the population. A statistic is a number that deals with the sample. How can you remember that? P's, S's. P's go together, the S's go together. Distinguish between descriptive statistics and inferential statistics. What do you think descriptive statistics are? Well, they do. They describe what's going on. Inferential, you guys have this trouble, and I have this trouble right now because I have a new teenage son that's just started driving. Inferential statistics is when you make an inference about something. All right? Why would driving be important? What do you have to have when you drive? That's true. License. What else? Insurance, right? And the insurance companies make inferences about you guys. What is their inference about drivers your age? You wreck a lot, you're not good drivers. All right? So they make those inferences even though maybe Molly's the greatest driver there ever was. Is that true? Molly. So they make inferences about you guys and they raise up your insurance rate because of it. Now all those inferences, they don't just say, you know what, we don't like these people, so we're going to raise them. They go by other statistics that showed them in the past, hey, this group of drivers has a poor rating. Now, just because 3 million 17-year-old drivers before you weren't good drivers, does that mean You're not a good driver? No, but that's what an inference is. Inferential statistics is when you make it, you look at something and you say, oh, well, the next pack of M&Ms I get, I expect that there's going to be fewer yellow and more blue. That's an inference. Does that mean it's going to happen? No. All right, data. Data consists of information. You probably know what data is. You can write that down if you want. Statistics is the science of collecting and organizing that and interpreting that data. This I might write down, a population. And again, when Ms. Clark writes this down, how are you going to define, do you really have to write down this whole definition? Population, I might write down like 2 words, maybe 1 word. What's a population? What's the 1 word there? All. Everything. Population's everything. What do you think the next term is? Sample. Sample is a subset. Population's all of it, sample's part. Those are the key things to remember. Population's the whole thing, sample's part of it. People who eat 3 daily servings of whole grains have been shown to reduce the risk of stroke by 37%. That's data. All right, just an example of kind of data. We're going to run through the statistics. Again, this is all just showing same stuff. See, statistic, we got everybody, sample, or I'm sorry, population, we got everybody. Sample, we just take a few of it, subset of it. In a recent survey, 250 college students at Union College were asked if they smoked cigarettes regularly. 35 of those students said yes. Identify the population and sample. This kind of stuff you're going to do on your homework tonight. What's the population in this case? Is it the 250? What's everything in this case? Union College students. That's your population. All right? And what's the sample in this case? The 250 that they polled. All right? So you've got to be able to pick that out. What's your sample? Is that right there? And where did that sample come from? Came from the entire population of students at Union College. In a recent survey, 1,708 adults in the United States were asked if they think global warming is a problem. What's the population this time?
United States.
Population. Adults in the United States. Adults in the U.S. And what's the sample? 1708, the ones that we actually picked out. So again, population is what are you drawing from? What's the whole set that you're drawing from? Sample is the part that you're taking out. And then the percentage that was on there, 96 or whatever, that was a piece of data. Parameter. A parameter is a numerical description. A statistic. A parameter is a numerical description for a population. Statistic is a numerical description for a sample. So parameter goes with sample, or I'm sorry. I'll do a long day. Parameter goes with populations. A statistic, not statistics, that's the whole course. A statistic goes with a sample. Your assignments on page 7, 23 through 48. Page 7, 23 through 48. Calculators. You need a TI-83 or 84 calculator. No ifs, ands, or buts about it. You're not going to be able to do this stuff without a TI-83 or 84 calculator. So get one. If nothing else, borrow one. Get on eBay, buy one. I bought 2 last year for like 20 bucks. Have a great day.